Throughout history, there have been moments when water did not gently rise with the tide, but instead arrived with overwhelming, violent, and unstoppable force. These were not seasonal floods caused by heavy rain, but towering walls of water that permanently reshaped coastlines within terrifyingly short periods of time. One of the most dramatic modern examples occurred in 1958 inside a narrow and isolated Alaskan fjord known as Lituya Bay. After a powerful earthquake shook the surrounding mountains, millions of tons of fractured rock collapsed directly into the confined inlet. The sudden impact displaced an enormous volume of water, generating a wave unlike anything previously measured by modern scientific instruments. The surge climbed to an astonishing height of over 500 meters above sea level, taller than many skyscrapers. Entire forests were stripped clean from steep slopes, leaving a massive visible scar on the mountainside that remains observable today. Two small fishing boats, resting quietly inside the bay, were suddenly lifted by the rising wall of water. Miraculously, one vessel survived by riding over the crest, while the other was destroyed in seconds by violent turbulence. This rare event was classified as a megatsunami, a phenomenon fundamentally different from typical ocean-wide tsunamis. Unlike traditional tsunamis that spread energy across vast distances, megatsunamis concentrate unimaginable power within confined geographic areas. Such waves are usually triggered by massive landslides, collapsing volcanic flanks, or sudden failures of unstable glacial slopes. Geological evidence suggests that in prehistoric times, even larger megatsunamis may have struck vulnerable ancient coastlines. Around 8,000 years ago, the massive Storegga landslide off Norway generated a wave that flooded parts of Scotland. Sediment layers discovered far inland reveal how deeply seawater penetrated communities that once believed themselves safe. If a similar undersea landslide occurred today, modern coastal cities could face catastrophic destruction within minutes of impact. Volcanic island chains also present significant risks, particularly when unstable slopes collapse suddenly into surrounding ocean waters. Scientists have long studied the Canary Islands, where a potential flank collapse could displace extraordinary volumes of seawater. Early computer models once predicted transatlantic waves capable of reaching the eastern shores of North America.
The model shows increased
Although
flood
more
risk in these
recent
areas.
studies suggest the
Right, we
threat
need to
may
factor
be
in the
less
erosion data.
extreme,
Adjusting
the scenario
parameters now.
remains
Watch the
under
simulation.
ongoing
Good,
scientific
the projection
debate.
is stabilizing.
Climate change introduces additional uncertainty as melting glaciers increase the likelihood of landslides in steep coastal environments. In narrow fjords or sharply sloped valleys, even localized collapses can generate towering waves within seconds. Early warning systems are often ineffective against megatsunamis because the wave can form and strike almost instantly. History repeatedly shows that when oceans rise without warning, survival depends on geography, awareness, preparation, and sometimes pure chance.